Hi students, my name is THIRUPATHI. Today I am going to discuss DC choppers, and I am working as an assistant professor in Marri Laxman Reddy Institute of Technology and Management. So in this DC to DC chopper, today we will discuss about step down chopper, and this topic will be covered in the power electronic subject. Okay, so now we will discuss. So here DC to DC converter. So first the function of the DC to DC converter is it will convert fixed DC to variable DC. So many applications wherever we are using the DC, there we required some voltage levels. That voltage levels may be increased levels, means that is step up levels and the step down levels. So if you take AC, in this AC system, if you want to increase the voltage, if you want to decrease the voltage, we have a transformer. So by using of the transformer, we can increase the voltage by doing of step up, and we can decrease the voltage by doing of step down. But the transformer can't used for DC system. So in this place, we are using the DC to DC converter, that is called as chopper. So by using of this chopper, in DC voltage can be increased by using of step up, and DC voltage can be decreased by using of step down. And here step up chopper is called as step down chopper is called as buck converter, and step up chopper is called as boost converter. So today we will discuss buck converter, that is nothing but step down chopper. So first we will see some points here. The chopper is used applications like DC motors control, electrical vehicles, and power supplies to adjust voltage level efficiency. Nowadays we are using the electrical vehicles. In this electrical vehicles, we have batteries. That batteries will store the DC power. So to conversion of some voltage levels, we have to use the DC to DC converters. Okay, and here we can see a block diagram. Here we have an input DC voltage or a power, and by using of DC to DC converter, we can change the output voltage. And here we have a fixed DC input waveform, and here we have a output waveform as a variable DC output. Okay, so this is nowadays more important. Why? Because today we are going to use the electrical vehicles moreover. And here the first point is step down chopper. So in the step down chopper, it is also called as a buck converter, and whatever the DC input we given, the DC input will be decreased by using of the step down chopper. So here you can observe we have a circuit. So in this circuit, we are giving the DC supply plus and the minus as a source voltage, and here we are using a switch. Okay, and in this place of the switch, we can use different types of power electronic devices. So we know the power electronic devices are power BJT, power MOSFET, and thyristor or SCR, and power IGBT. So in the place of this switch, we can use any device according to our convenience and the power ratings. So moreover, we will use the thyristor for higher ratings, and for moderate purpose, we will use the MOSFET or the IGBT. And here we are connecting a diode across the load. That diode is called as a freewheeling diode, and here we are using a load RL. Okay, so this is the circuit. Now we will discuss about the operation of the circuit. So if you see here, the operation of the circuit. So before going to the operation of the circuit, we have to discuss about the time domain. So here we are using the total time T. That total time can be divided into two parts. One is turn off time, and another one is the turn on time. The switch operation time means the switch is on time and the switch is off time. That should be maintained in between the T. So why we have to maintain in between T means there we have some time ratio methods. So we will discuss in the next class. So now we are taking a time, total time is equal to T on and the T off. So here first we have to see the switch is on. So when the switch is on, then the current will flow from the switch source to the switch, and here the freewheeling diode will be act as a reversed bias, so that the current will not flow through the freewheeling diode and the current will flow through the load. Okay, so here we will get V naught is equal to Vs. V naught is equal to Vs. Okay. So in this time, if you observe here, this is the source waveform. We have a straight line, and here the variable voltage. So when the switch is on, here the voltage will be there. Okay, right? So at a turn on time, we will get a output voltage. So after some time period, we will turn off the switch. So after turning off the switch, then the current at output voltage is 0. Okay, current will become 0 as well as the voltage also 0. Why? Because it is a resistive load, so that the output current is 0 and the output voltage is also 0. So that we will get the output as a 0. So when it is on, we will get a output voltage V naught is equal to Vs, and when it is off, we get output is equal to 0. So by this, we can observe the fixed voltage into the variable voltage. Okay. So here the voltage and the current both are similar. Why? Because it is a resistive load. So this is the voltage waveform. This is the current waveform. Okay. So in this current waveform also, I naught is equal to Vs by R. So here when it is turned on, we get a some value. So when it is turned off, we will get a 0 value. So by this switching operation, turn on and the turn off, we will get the output voltage as a fixed voltage to variable voltage. Okay. And here now we are going to discuss the average output voltage equation. So let me see here. We know V naught equals to the total time period 1 by T, and the switching period is 0 to T on. So here the function is source voltage Vs and the dt. So this is the average output equation. So now from this we will find the value. So 1 by T, the Vs is taken out, and integral of 0 to T on, and it is 1 dt. So here Vs by T, integral of 1 is nothing but T, and we have a limits of 0 to T on. So substitute the limits. So we will get Vs by T. So here T on minus 0, the upper limit will be substituted first, after that the lower limit. So that we will get Vs by T and the T on. So V naught is equal to Vs into T on by T. Okay, so here T on by T is nothing but a duty cycle. So it can be denoted with capital letter D or an alpha. So we are denoting with alpha. So alpha Vs. So this is the average output voltage equation for the step down chopper. Okay. So V naught is equal to alpha Vs. So for this circuit, we can also derive the RMS voltage equation. Okay. So VRMS equals to under root of 1 by T, integral of 0 to T on, and Vs dt. Okay. So here again we will take Vs outside. So Vs by T, and so here we have a Vs square. The function will be square. Okay. So Vs square is taken out. So here integral of 0 to T on and 1 dt. Here under root of Vs square by T. So if you integrate 1, we will get the dt. So the limits is 0 to T on. So Vs square is be taken out, so that the under root and the square will be cancelled each other. So Vs, and here 1 by T. So limits will be substituted, T on minus 0. So Vs into under root of T on by T. So in similar way, the duty cycle is T on by T, so that here duty cycle is denoted with the alpha. So VRMS of the step down chopper is Vs into under root of alpha. So this is the equation of average output voltage equation, and this is the equation of VRMS output voltage equation. Okay, and here we can see the step down chopper with the inductive load. So step down operation with the inductive load. Here if you observe, the output voltage of R load and the RL load are same, but the output current of R load and RL load is different. Okay, in the R load, the output voltage and the output current both are similar, but in the RL load, the output voltage and output current are not similar. Okay, so we will more concentrate on the output current. Okay, so in the same manner, we know when the switch is on, the current will flow through the L to the output. Okay, and the voltage V0 is equal to Vs. So here we will get in the on time V0. So after some time period, we are going to turn off the switch so that the output voltage equals to 0. So in the turn off time period, we will get 0. Okay. So now we will discuss about the output current, right? So due to the inductor, we know the inductor property, it will not allow the sudden change of the current, so that slowly the current will be increased and slowly the current will be decreased. If you see, when the switch is on, the current is passing through the inductor. So the inductor slowly storing the energy. Okay, so slowly it is increases to the maximum value. So at this point, we are going to turn off the switch. So now we turn off the switch. Now this inductor act as a source and it deliver the energy. So slowly it will deliver the energy. Okay, so here if you observe in this, the output current is not going to reach 0. It is not going to reach 0. So this is called continuous mode. This is called as continuous mode. So see here, so when the current is passing through the inductor, slowly it goes on increases. So when the switch is turned off, then the inductor will be act as a source and it slowly discharges. So when it going to become a 0, again we turn on the switch, again it starts storing the energy, so that the output current is not going to become 0. So it is called as a continuous mode. If any time delay, we have a time delay, so that the current should be reached the 0. Let us see here. Here it is started from the 0. And slowly it is increases. Okay, and this energy will be decreases for a time period, and here we are not going to turn on, so that it becomes 0. Why? Because at that time the output voltage is 0 as well as the inductor voltage is also 0, so that we will get output is equal to 0. So after some time period, the switch is on. So when the switch is on, again it will be increases, again it will be decreases. So here again the inductor voltage is 0 and output is 0. So we are getting the output almost is 0. So again when the switch is on, again it increases, again it discharges. So that here we are observing the waveform is, it is reaching to 0 and we are getting the output current is 0. So when output current is 0, and that is called as discontinuous mode. Here the current is not becoming 0, but here the current is becoming 0. So this is the continuous mode and this is the discontinuous mode. Okay, so by using of the R load, the output current can be make into continuous as well as the discontinuous by doing of the switching operation. So here we have some advantages of the step down chopper. We will see here. It reduces the input voltage to a lower level, making it a suitable application where low level voltage is required. So when we are giving a DC supply to the electronic circuits, in that electronic circuit, so many components have different voltage ratings, so that it will be by using of this chopper, we can change the levels of the voltage and that voltage can be supplied to the different devices. And they operate at high frequencies, they experience low switching losses compared to low frequency counterparts, so that efficiency improves and power losses reduces. Okay, so by doing of switching operation, the frequency will be changes. Why? Because the frequency is inversely proportional to the time period, so that if you change the time, then the frequency also changes. And here they provide a regulated output voltage even when the input voltage fluctuates. So in the isolated transformer, if input side AC voltage is fluctuated, the output voltage will be maintained constant. So how much the voltage we required, that can be achieved by using of the transformer. In the same manner, in the input side, if any voltages are fluctuated, the output voltage will not change. So whatever the voltage we required, that voltage can be achieved. And next one, this maintains stable power supply for sensitive electronic components. So we know in the electronic components, if there is a change in voltage or change in temperature, then the devices undergoes into the malfunctions. So we have to maintain a constant voltages. So by using of this DC to DC converter, we can achieve that. And the next one is, it is in compact design. So transformer in AC to AC, the size of the transformer is very huge, okay, but in DC to DC, we are using a small chip, so it will have a compact size, because the size will be reduced. We are using a power electronic device, and as it reduces the voltage, the power dissipated as heat also reduced compared to the linear regulators. By using of another regulating methods, we will get some heat losses is more compared to our DC to DC converter. Okay, so these are the some advantages of the step down chopper, and we know every human being and as every device have some drawbacks. So in this step down chopper also we have some disadvantages. Okay, so here it can introduce output voltage ripples due to the switching nature of the device. So this voltage ripple is a problem in the total power electronic devices. Why? Because while doing of the switching operations, the ripples will be produced. So not only this DC to DC converter is facing this problem, but also inverter, rectifier, cycloconverter, etc., all the devices where we are using the switching operation, there the ripples problems will be there. And rapid switching of the semiconductor device in step down chopper can generate electromagnetic interference. So while doing of the switching operation, turn on and the turn off, the frequency will be changes, so that whatever the neighboring communication lines are there, that lines also get some disturbance by interfacing of this DC to DC converter and the communication line. So communication line is also depending upon the frequency. Here we are doing the switching operation. So switching operation is doing nothing but turning on and the turning off. So the timing is going to be changed. So if the time is changes, then the frequency will be changed. So by changing of the frequencies, there is a chance of interference of communication in the DC to DC converters. Okay, and last one is semiconductor devices such as the power switches may experience high voltage stress during operation. So by doing of multiple switching operations, there is a voltage stresses that will be happen in the step down chopper. Okay, and here we have some applications. Okay, so we've seen the operation, we've seen the advantages, we've seen the disadvantages. Now we have a applications. Okay, so these are commonly used in the DC motor speed control application. In the DC motor, we required a DC controlling system. So here DC to DC converter is a fixed DC to variable DC converter, so that it can be used for DC motor speed control applications. And next one, in electrical vehicles, these are used to control the power supplied to various components, including the traction motors. Okay, so we are using the charging motors. So in the charging motors, we have a batteries. That batteries will store the energy. So whatever the energy is stored in the battery, from that battery we have to supply for various systems like the traction motor in the vehicle, as well as for the lighting purpose, any other applications in the vehicle. So it required a different voltage levels. That different voltage levels can be achieved by using of this DC to DC converter. And the next one is, these are used in telecommunication power supplies. So there also we require DC batteries, so that we can use these converters. And in UPS systems, step down choppers are used to regulate the voltage and maintain stable output during the power interruption. So in homes and in industries levels, we are using the inverters, but that inverter is connected to the batteries. So that battery is DC. For that DC purpose, for the DC, the voltage should be a constant. For that regulating of the maintaining of constant voltage, again we are going to be use the DC to DC converter. And last one, these can be utilized in energy harvesting system to efficiently convert and manage energy from various sources to power low electronics. So simply we can say that wherever we required the DC output voltage to increase or a decrease to maintain a constant without any fluctuations, there we can use this DC to DC converter. We can decrease the DC output voltage, we can increase the DC output voltage, we can maintain the constant DC output voltage. So these are the DC to DC copper chopper. Okay, so here we learn what is a DC to DC chopper, DC to DC converter, and DC to that is a chopper, and we learn the step down operation, how the circuit is on. So when it is on, what are the waveforms we have observed in the R load, and how the output current is going to be vary in the RL loads. Okay, and we seen the derivations of average output load and VRMS output voltage, and this is the operation of the inductive load and advantages, disadvantages, and the applications. Okay, this is about the step down chopper. So thank you.